Hello, everyone. My name is Dr. Shana Gifford. I am a rehabilitation physician at Washington University, St. Louis. I am also a simulated astronaut who spent 380 days in space analogs. I'm here to walk you through why living, working, and conducting biomedical research on the moon is a necessary step towards successful settlement anywhere the gravity fields are neither 1G nor microgravity. In order to accomplish this in 300 seconds, I'm going to focus on one vital human function: personal propulsion. On Earth, in 1G, unadapted humans use walking as their primary means of propulsion or locomotion. Adapted humans with spinal cord injuries, amputations, certain neurologic conditions may use wheelchairs, walkers, exoskeletons, or artificial limbs to achieve propulsion or locomotion. In low Earth orbit, personal propulsion is achieved inside the station by means of pushing, pulling, inertial sailing, and hand-over-hand type climbing motions. Here is why this matters. To maximize function and avoid injury, humans must continuously optimize how we propel ourselves. Decades of research and practice have yielded best practices for personal propulsion in 1G. Humans walking unassisted on Earth achieve a safe, stable gait by accepting weight onto one limb while activating the hip flexors for stability in that limb as our entire body weight shifts. At the same time, we pick up the opposite foot and advance the opposite limb. Then the other side mirrors that motion. This is called the gait cycle. And this gait cycle I just described to you involves the legs spending about 60% of the cycle on the ground and about 40% swinging. On Earth, that ratio of stance to swing is considered to be the most biomechanically efficient, effective, and safe way to walk. Walking with this ratio allows critical events like heel strike and leg loading to occur with a frequency and duration that loads bones and works muscles, preventing loss and atrophy of tissues that have evolved to work together in a balanced and coordinated fashion. The instant the gravity shifts, the dynamics of personal propulsion shift too. It has been documented in at least one study on Earth that when you offload 80% of a healthy human's body weight with a harness for brief periods of time, they respond by drastically changing their walking style. Walking in simulated near-lunar gravity, humans have been shown to reduce their hip range of motion, decrease their walking speed, and take shorter strides. And even though they're moving their legs less in near-lunar simulated gravity, the whole gait cycle takes 26% longer. The hip flexors and toe flexors do dramatically less work, while the muscles that push the toes off the ground seem to do closer to the usual amount of work. In the short term, this new pattern of muscle use and disuse may not affect function much. In the long term, it almost certainly will, as some lower extremity muscles become dominant over others, causing muscle, gait, joint, and functional imbalances from walking in this new way all day, every day. How dysfunctional will we become if our gait cycle is thrown off like this? We don't know. We do know, as of now, that the force of heel strike when walking in only 20% G has been shown to decrease by as much as 33%. That's kind of like somebody walking with a case of tendonitis. Is the remaining force of heel strike enough to prevent atrophy of the calcaneus and femur, like the kind that we see in microgravity? Well, we don't know. If not, what technological interventions can be used to simulate or induce the ground reaction forces humans need to maintain homeostasis and peak function when we're offloaded by 80%? Well, again, we don't know, but we could know. If only we had somewhere to go to study that. Well, by happy circumstance, Earth's only natural satellite provides a level of constant gravitational unloading, consistent with our need to study how much gravity people functionally need to walk well, to prevent significant bone loss and muscle atrophy, and to maintain peak performance. Once we understand the amount of gravity humans need to be loaded with to achieve our optimal biomechanical, cognitive, and sensory organic functions, we will be able to take a next step into deep space. There's no platform more accessible for these studies than the lunar surface. The sooner we master moonwalking, the sooner we'll walk out into the stars. That's my 300 seconds. Thanks for listening. Here are some references. Please send questions to the email below.